Listen. So very good day to everybody. This is Electromagnetic Fields and Waveguides, the practical session. We'll discuss about PLC, Power Line Communication, in our today's class. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants, students and young researchers. So in this class, we'll discuss about PLC, Power Line Communication, and about the PLC technology, how it actually works. Okay. We'll discuss about the types of PLC, Narrowband and then Midband PLC. What are the connectivity technology that is going to solve a variety of problems. Okay. So then we'll discuss about the example of usage of power lines as communication lines, especially for the HVAC type of system, building air conditioning system. Then we'll discuss about the types of the power line communication, then the advantages and disadvantages of PLC, comparison of PLC with the Wi-Fi and Ethernet. Okay. So then we'll discuss about the applications of the PLC. So at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. Right. PLC. It's not programmable logic circuits, but it's a power line communication. Okay, so power line communication, it's of course, it's a data transmission technology using like cables, like maybe power lines, coaxial cable, or maybe twisted pair cables. So using this cables as a transmission medium, you can, build a network at a very low cost. Okay, so that is the advantage of the power line communication. So maybe if you are using power lines, so power transmission as well as data transmission can be done with a single cable. So that can reduce the types of the cables in the network. So here we will have the power line like a car, okay, that is charged, lamp, light, charge, okay, TV, charge, okay, so washing machine, charge, okay, even the hojat that you try to use, that also something, water, heating, everything charged. Okay, everything it will go on. Okay, to connection through the internet. Okay, so we'll have like AC control wire, control cable, coaxial cable, wired intercom cable, power lines, coaxial cable. So everything we'll see. For example, AC control wire to the air conditioning system, solar power generation to the solar cable. Okay, so we'll have like control cable, coaxial cable to the elevator, so that is maybe connected to the coaxial cable to the TV, telephone lines to the phone for the landline phones, okay, or maybe internet you'll try to use. Okay, then we'll have wired intercom cable connected to intercom, okay, within the business building, business company, everything you connected with the intercom. Okay, lighting to the power lines, security camera, power lines, okay, and we'll have like power lines and lighting control cable. So for everything we'll have power line communication. So this is the PLC technology. We'll have data signal being passed on to the PLC device, so that is passed on to line, okay, PLC device. We'll have the line to line communication to the data signal. Okay, so we'll have like power line AC, voltage in line, the other line you'll have a DC, same signal. Then we'll have the modulated data. Okay, so you'll have the modulated signal. So this voltage in line along with the modulated data, you'll be getting a superimposing signal like this one. Okay, and you try to extract the signal, reconstruct it to get the original signal. So when transmitting and of course receiving data between two devices, the data is actually modulated on the transmitter, and the modulated signal is superimposed on the AC power supply or maybe DC power supply voltage. Okay, so in the receiver, the data is actually extracted by separating this power supply voltage and the modulated signal with a filter, and of course you are going to demodulate the modulated signal. So PLC, you can use it in the AC power lines, but keep in mind that you can use it in the DC power lines. So more it will be used in the DC power lines. For example, for usage for the storage batteries, lighting, what you see, okay, EV charging. So everything you will be using this PLC technology. Okay, so the power signal will have here, and this is the modulated carrier. Okay, we'll try to employ this PLC technology. So these are the types of PLC technology. We'll have like narrowband, midband, broadband. So narrowband will have G3 PLC, frequency range lesser than 148.5 kilohertz, lesser than 490 kilohertz. Okay, for forward channel. Okay, transmission distance is long. Physical layer speed is lesser than 280 kilobits per second, and for FCC it is lesser than 1 Mbps. So you see the standard. Okay, ITU-T, International Telecommunication Union T standard. Okay, G9901, G9903, and IEEE 1901.2. Okay, similarly for the FCC we use ITU-T G9901, 9904, and IEEE 1901.2. Okay, and for midband we'll have HPLC, high power line communication. So 0.7 to 12 megahertz for the middle distance, and physical layer speed would be 150 kbps to 10 mbps. Okay, and HD type PLC. Okay, mid to short. So it will be 62.5 mbps to 1 gbps. Okay, and HomePlug will be using 1.8 to 50 megahertz. So that is the frequency range, and physical layer speed it will be 200 mbps to higher 1.3 gbps. Okay, broadband will have HD PLC 1.8 to 100 megahertz, middle to short. So 62.5 to 1 gbps will be having. Okay, and you'll have GHN 2 to 200 megahertz. It will be short, but it will be 300 mbps to 2 gbps, much more higher speed. Okay, so G3 PLC, we'll discuss about this one. It's a narrow band PLC technology managed by the G3 PLC Alliance. Okay, so the standards we have like G9901, 9903, and IEEE 1901.2. Okay, so you can enjoy physical data services up to 280 kbps, especially in the full channel communication band. Okay, then we'll have prime. Prime is power line intelligent metering evolution. Okay, so it's a narrowband PLC technology which is managed by the Prime Alliance. So same like this one, we'll have G9901, 9904, and IEEE 1901.2. Okay, physical data rate you can see 1 Mbps speed you can get in the FCC mode. Okay, then the second type, midband PLC. So it is HPLC. Okay, so it's a midband PLC for smart meters, smart traffic lights. For example, traffic light, every time you need not have people to operate. Okay, smart. Okay, maybe after 6 o'clock automatically it will dim, or maybe it will become bright. Okay, like that. Okay, so the related standards is IEEE 1901.1. Physical data rate is up to 10 Mbps. Okay, then like HPLC we have broadband PLC. We'll have HD. What is HD? High definition. Okay, so high definition PLC, it's a broadband PLC technology managed by the HD PLC Alliance. Okay, so the related standards are IEEE 1901 and G9905. So earlier we used 9904, now 9905. Physical data rate is 62.5 Mbps for longer range, and for higher speed we will be getting 1 Gbps. Okay. HomePlug, as I told you, it's a broadband PLC. Okay, by the HomePlug Power Line Alliance. Related standard is IEEE 1901, and physical data rate you are enjoying high speed 1 gigabits per second. Okay, then we have GHN, Gigabit Home Network. So that is a broadband PLC technology managed by the Home Grid Forum. So we'll have 9960, 9961, 9962, 9963, and 9964 types of standards. Okay, data rate is much more higher, 2 gigabits per second. Okay, so Ethernet, Wi-Fi, PLC. You can see, you can compare. Even power line communication is achieving, greater feat. Okay, with regards to speed, stability, easy to connect, installation cost is very less, mobility we are enjoying with this PLC, power line communication. Okay, so both you cannot say PLC does not have disadvantages. It has some advantages, disadvantages. That is how you try to build a network with a moderate performance, and of course it is satisfying the requirements of the Internet of Things, IoT applications. Okay. Also, it's a low cost available. Okay. So PLC devices, you can eliminate a variety of issues by reducing this cable installation. You can enjoy high speed, and of course it is very robust and highly reliable. Okay. So the technology will allow power lines to be used as a communication lines, especially for transmitting the sensor data, audio data, and several visual data even. Okay. So the features will have the ability to use power lines as communication lines. You can reduce or maybe eliminate the cable installation, and of course you'll go for OFDM. Okay, multi-carrier orthogonal frequency division multiplexing, especially for high speed and robust reliable communication. Okay, so we'll have error detection schemes as well, especially in this PLC, and of course correction functions that are available for higher reliability. Okay, then we'll have DSP, digital signal processing based software modem, which is going to accommodate what are the upgrades, what are the updates, especially for supporting different standards. For example, this particular system will support this standard. Maybe another upgrade comes, maybe the earlier standard it will not support. So that everything it is trying to support the standards, and also you are going to improvise the performance. For example, earlier it was like 500 Mbps, now 1 Gbps, then 2 Gbps. So this is how you are enjoying the benefits. Okay, so no expensive wiring is actually needed because it is much of less cost. So we have like shielded or maybe twisted pair cables. Okay, so that is what is required. So that will make the housings much more comfortable, much more compact, and of course reduce cost even. Okay, right. So we'll have this multi-carrier modulation, which enables high speed and of course robust communication. So the single carrier is transformed, okay, into multi-carrier with the corresponding frequency. Okay, so here the PLC data transfer does not use subcarriers or maybe tones, which communication line is poor due to the higher noise levels. So we'll assure better communication through the power line communication. Okay, so that it is going to transform into the signal with lesser noise. Okay, so there is no need to worry about like increased complexity. For example, the system is becoming more and more complex. So what will happen to the power line communication? So that is the advantage that we will enjoy with the power line communication. Okay, and of course there is no need for the additional wiring also. Okay, so that will go for increased reliable information collection. Okay, and of course use of sensors. So that is the advantage that you will enjoy with the power line communication. Okay, so these are the examples of the power lines used as communication lines, especially for the high voltage AC system or maybe building air conditioning system. Okay, so we'll have DC 24 volt for the general purpose controller. The cable length is up to 5 meter. Okay, so we'll have like resistance temperature detectors. Okay, we'll have a 4 wire, we'll have the current 4 to 20 milliampere communication cable. Okay, but here the cable length would be 10 to 20 meter. Okay, so we'll have the sensor just to catch the signals. Okay, we'll have the flow meter event. So no signal lines, reduce cable installation, longer distance, and of course multiple connection points we'll have with PLC. Okay, especially with the in large setup. Okay, we'll have like MCU, PLC, we'll have the DC 24 volt 200 kbps communication. Total cable length would be like 2 kilometer, that much distance. Okay, so we'll have PLC, MCU, AFE, okay, everything being connected for the flow of lines. So this is the example of use of power cables as transfer routes for the audio data. Like we'll have monitor. Okay, like monitor you have, then you have a microphone. Okay, so PLC master will have MCU. Okay, will have PLC. So everything will have from master to the slave, everything being connected, okay, to the speaker. For example, I am speaking, okay, maybe there is a speaker there, maybe another room there is another one speaker there. So this will act as the master, maybe the other rooms will act as a slave. Okay, so these are will have the 4 types of PLC: power line communication, in-house networking. Okay, so here high speed data transmission can be provided for the home networking using the in-house mains power wiring. Okay, then you have broadband over the power line. So broadband internet access maybe through the outdoors, okay, mains power wiring you can offer them. For example, broadband you will have in your room, okay, maybe in another room you want to enjoy, so that you can enjoy, you can connect. Okay, then you have narrowband in-house applications. So low bit rate services, maybe like home automation. For example, I use my mobile to turn off the lights, okay, for that low bit rate service, okay, or maybe intercom, so that can be controlled, and you can use it for communication through the in-house power mains for this narrowband in-house applications. Then we have narrowband outdoor applications. For example, automatic meter reader system, okay, or maybe remote surveillance or control, that you can use it for outdoor applications. Okay, maybe like outside you are in your company and oh, I forgot to switch off the light, immediately use the mobile control, immediately it will switch off. Okay, so this is the types. Okay, 4 types of PLC, 4 types of power line communication. Then we'll discuss about modulation schemes used in PLC. So we'll have OFDM, orthogonal frequency division multiplexing, BPSK, binary phase shift key, FSK, frequency shift key, SFSK, spread frequency shift key, and of course we'll have like DCSK, differential code shift key. So OFDM will have high data rates, but it requires some computational horsepower for the FFT, fast Fourier transform, and inverse fast Fourier transform output. So we'll have BPSK and of course FSK, much more standard, and simple modulation schemes that can be used with PLC can offer low data rate. So that is the advantage you will use. Okay, so currently like running modulation scheme for this PLC is you use this OFDM, orthogonal frequency division multiplexing, with the phase shift keying modulation that allows you to enjoy the benefits of the high or maybe heavy computation. Okay. So the advantages: lower implementation cost. PLC does not require any installation of new wires, so that is the reason it is decreasing the deployment cost. Of course, larger reach. Okay, like we will see like a connection with the data acquisition center through the radio, Ethernet, GPRS, okay, or maybe optical fiber. So the data connector, you are connecting to the smart meter with a PLC modem, smart meter with a PLC modem, different places we are connecting. So with PLC power line communication, you can enable communication with hard to reach nodes as well, where the RF wireless signal suffers from higher levels of attenuation problem, okay, like underground structures or maybe buildings with obstructions or maybe metal walls. So there we are enjoying the advantage. Okay, right, so we'll have hard to reach nodes as well. So here the wireless signal is undesirable because of the EMI issues in the hospitals. Okay, so that is the advantage. Lower running cost. So PLC offers a low cost solution, okay, compared to maybe RF wireless or maybe visible light communication, VLC type of systems. Okay, then we'll have indoor high speed. Okay, when you try to implement the PLC or maybe VLC technologies integrated together, okay, so that has come out with a lot of more people are much into it. Okay, so which results in the generation of the high speed indoor communication for several applications. So that is the way everywhere you see power line communication networks being developed for the student projects even. Okay, so that whatever your advantages will have, you have the disadvantages too. So disadvantages: transmission speed is very less. It is much more sensitive to disturbance. Okay, non-linear distortion problem is there, cross modulation problem is there between the channels. It's larger size. Okay, the capacitor price is high, inductor price is high. Okay, especially in the PLC type of system. Okay, so that is the reason PLC is still not preferred. Okay, in the applications. We'll try to compare with the Wi-Fi and Ethernet. So whenever you compare with Wi-Fi, there would be some concerns with the interference as well as security. Okay, but feel the cost of the network using Ethernet is actually high. PLC can definitely offer a much more optimal solution as the new option. Okay, so you can benefit a lot of advantages by building a hybrid network of this PLC, power line communication, and of course the Wi-Fi. Okay, so there are some pros and cons of PLC. So you are going to compare PLC with the Wi-Fi and Ethernet. Okay, so pros and cons of PLC are not fixed and depend on what you are trying to compare. Okay, so an advantage that you will enjoy when compared to Wi-Fi can be a disadvantage compared to Ethernet. So that you cannot say, okay, this is best and this is worst. Not like that. Okay, so that is the thing. So advantages, we'll try to compare with the Wi-Fi, higher security. So there is very little risk of data eavesdropping, very little problem of data falsification. Stability, even the change of the transmission characteristics due to this surrounding environment is very small. So you can maintain a constant performance with the PLC. Okay, and of course it's a complementary to the wireless. So data transmission using this existing cables is possible even when the radio waves are much more harder to reach. Okay, even like underground, elevator, steel ship. So we'll have definitely an asset to the wireless technology. If you compare with the Ethernet, we'll have low installation cost. So installing new hub as well as new cables for relaying is not needed. Okay, but if you try to compare with Ethernet, we will have many disadvantages. Okay, lower speed. So maximum speed in the standard is actually lower than the Wi-Fi. Okay, when you compare, Wi-Fi is having more speed, like 9.6 gigabits per second. And mobility, the place of the communication equipment is fixed if you try to compare with the Wi-Fi. Okay, and with the Ethernet, okay, like lower speed, like maximum speed is actually lower than the Ethernet. Okay, 10 gigabits. So that's again a disadvantages with the PLC communication. Then of course with the Ethernet, it is having an unstable environment. So here the noise from the connected devices is going to still go on and on with the power lines. Okay, so applications, where is power line communication being used? Okay, so PLC technology, you can use it to empower smart building, smart factory, smart grid, smart city. Okay, so that is the solution in order to reduce the network construction cost. And we have AMI system. Okay, advanced metering infrastructure system, micro inverters, HVAC system, as we saw, building air conditioning system, elevators. Okay, we will be using this one. Also in the storage batteries, smart street light, lighting control system, intercom system, security camera system. Okay, you can use it. Okay, even in the automotive sector, aerospace sector, industrial robo, we are using this power line communication.